Hey guys, we're going to go ahead and do the third example from class that we didn't have time for, and here it is right here. So take a moment and read it. Maybe pause the video like before, give it a shot, at least draw it, label it, and then see if you can get it. Then come back to the video and see how you did. Okay, so hit pause, draw it, and see what happens. Okay, so let's go ahead and just start translating. You're looking up at a flagpole. You're looking up at the school's flagpole right outside the front of the school. Okay, that's not too bad. So here's the flagpole, right? And you got your flag. You got your stars and your stripes. Yay, America. Okay, so you got your I know it's not accurate. Whatever. Don't judge me. So you're out there and you're looking up at it. Okay, that happens. I'm sure you've done that before. Okay? And alright, so what's next? They say we're just looking up at it. Fantastic. You are looking through a transit up to the pole at an angle of 28 degrees. Ah, okay. So a transit is a tool that the engineers use, like on the side. You ever see on the side of the road where the guys are there and they're looking through, it's like on a tripod. It almost looks like they're looking through a camera. That's actually a transit. So what happens is, it usually is on a tripod, and it's got some kind of adjustable pole that you can make higher or lower, and it's actually like it's almost, I don't want to say telescope, but it has the ability to look through and measure angles. So if you're looking through it, you can actually measure the angle of elevation of whatever you're looking at. Okay, that's not the best picture of a transit, but that it's basically something you could look through. It's almost like a protractor, but a lot more accurate. So you lift it up, you lift it up, you lift it up until you see what you want to see, and you stop, and then you get the angle you want. So that's basically what's happening here. If we look at the information, they're saying we're looking up, and we're seeing a 28-degree angle. So if this goes up to the top of the pole, according to the measurement, based on the horizontal, I've got 28 degrees right here. Okay, remember, angle of elevation goes from the horizontal, not from the, from wherever it is horizontal. If this was on the ground, if somehow you were lying flat on the ground looking up and you measured that angle, it would be down here. But this is where the actual transit is located, so we're just following what they're telling us. And then, of course, this has to be perpendicular, just like this would be. Okay? There's the ground. And I think we've translated so far so good. So you're looking up at the flagpole at an angle of 28 degrees, and the transit is 5 feet 6 inches off the ground. 5 feet 6 inches off the ground. So from here to here is 5 feet 6 inches. Right? That's this way. 5 feet 6 inches. That's the transit. And then I think there was one other thing. And it's about 46 feet away from the flagpole. Okay, so from here to here is 46 feet. Well, if here to here is 46 feet, well then here to here must be 46 feet. So that's 46 feet. And then, of course, I'm sure you probably already could guess, they want to know, after we draw it, they want to know how high the flagpole is. Okay, so the flagpole, again, just like when we did the kite, goes from here to here where our horizontal was, but still all the way to the ground. Oops, sorry, that didn't stay straight. It goes all the way up. That's not my best work. All the way up from the flagpole, top of the flagpole, all the way to the ground. Well, if I could figure out what this part is, I can certainly just add in this 5 feet 6 inches that we are given for the transit. And that's how these kind of problems work. So here's our angle. We know this piece, which of course you know now is the adjacent. We're trying to find the opposite piece. I don't even care about the hypotenuse. Who cares? At least for this one, right? We don't need the hypotenuse. So let's not bother with it. We need the opposite because that's what they're asking for, and they gave us the adjacent. Which trig ratio uses opposite with adjacent? Okay, if you go back to our notes, SOHCAHTOA, we need opposite with adjacent. So this was opposite with hypotenuse. This is adjacent, but with hypotenuse. Opposite with adjacent is tangent. So the tangent of 28 degrees equals opposite divided by adjacent. And now we can figure out at least this piece, this portion of the pole itself. So let's get tan of 28. Tan 28. 5317, so 0.5317 equals x over 46. Let's do our usual thing so we don't mess up. This one works out nicely again, x times 1. I love when that happens because then we're done. Once we get this number, we are done. 46 times 0.5317. And I got 24 I don't know, let's call it 5 feet. Now, I sort of said we are done, but what I meant was we're done solving for x. We didn't have to do any division. With this problem, as we said before, I think I cut off the picture there. As we said before, we need to find the total height of the pole. The 24.5 is just this part. Plus 5 feet 6 inches. Well, 6 inches is half a foot. So this is actually 5.5 feet. So 24.5 plus 5.5. And if you wanted to, you could have converted it to inches or however you wanted to do it. But I do need to combine those. So 24.5 plus 5.5 is pretty much spot on 30 feet. And there's our flagpole. Okay, so hopefully that helps. Again, if you have any trouble or you need me to do any specific problems, you just have to ask. You guys just have to ask. You got to take the time and look at it. And if you have trouble, you have to ask for help. Okay, talk to you later, and hopefully this helps for your warm up tomorrow. See ya.